This video was intended to be made about a month ago, prior to the COVID-19. It's essentially a theory on the correlation between different types of programs for artificial intelligence and their relation to feedback loops between cognitive functions in Jungian psychology, which are metaphors for different regions in the brain. So, these are the cognitive functions in Jungian psychology: extroverted intuition, introverted intuition, extroverted sensing, extroverted feeling, extroverted thinking, introverted thinking. You can just clearly think of introverted sensing as a storing of memories of sensory perceptions as hippocampus related, roughly introverted thinking as planning, something like self-referential thinking as prefrontal cortex. Introverted feeling is something like striatum, nucleus accumbens, hypothalamus, the dopaminergic system, value forming. The extrovert sensing would be something like the sensory cortex, the sensory motor cortex, and the extroverted thinking would be something like the cortex that does top-down regulation. An extrovert feeling would be something like the corpus callosum. Those are just parallels that would take a bit to get into, but I've just seen between the ideas of these cognitive functions and different activations of different brain regions. So then, if you categorize these functions, you put them into internal consistency and internal space, external consistency and external space. Essentially, you have these functions such as introverted intuition, which is related to will, introverted feeling related to value, introverted sensing the archetype, introverted thinking logic, and then you have the extroverted functions. Extroverted intuition is like exploration in AI, you also call it connection here, morality for extroverted feeling, perception for extroverted sensing, and knowledge for extroverted thinking. This extroverted space is a little more intuitive, so I'll start with that one. The extroverted space, the only things that I could think of that would kind of match these in terms of AI, because of course we don't have a very good set of programs for these, is Professor Tenenbaum's work at MIT related to unsupervised and supervised learning related to intuitive psychological programming and intuitive physics. So based off of the combinations of the loops here, when you actually look at Jungian psychology, you can see that you can get these loops between extroverted intuition, extroverted feeling, or extroverted feeling, extroverted sensing, or extroverted sensing and extroverted thinking, and vice versa. And so something like exploration of ethical moral space would be something like intuitive psychological programming, which Tenenbaum's unsupervised learning we're working on. I had references to other programs like autoencoders, restricted Boltzmann networks, but I can't remember at the moment because I'm just doing this to try to erase it from my whiteboard right now. There are references to some ideas that I had in the past. Differential programming has been a really cool idea that might be useful for haptics, which then might get relayed as an input into these systems, so that's why I had that here. And you'll notice that in each section I put local orchestration, QRA, or quantum reduction algorithm. So I put that in all of them. It's just to say that there's a class of, and then this bracket system, there's a class of quantum reduction algorithms that work most efficiently for these specific modalities of mapping external space or external consistency, or internal consistencies, or internal space. So another one that's kind of intuitive is the internal consistency. So if you've heard of Stephen Wolfram and his programming symbolic coding languages, Mathematica, and others, this is more like what you would think of as a recursive loop between a memory to logic feedback loop. It kind of made me think of recurrent neural networks, which are best for time series analysis like text, natural language, and speech. Facebook has this kind of cool syntactical tree program that was used to treat mathematics as a language so that it could learn how to solve regular equations, similarly to how the symbolic language coding for Stephen Wolfram, which was built from the ground up, lets it have this abstract, which is the logical part, connection between different archetypes. And then there's the internal consistency of will and value loops, which are the more traditional version of narrow, weak AI. The gradient descent optimization, and most people have heard of Andrew from Stanford and his online class for that. There's a lot of exploiting this cost or reward function, as they're usually called, for the sake of maintaining the rate of change of the gradient descent or ascent, that's why it says vanishing or exploding. Then there is internal space. So the internal space I think of as the left hemisphere acting on the right hemisphere, the left hemisphere acting on the left hemisphere, the right hemisphere acting on the left hemisphere, and the right hemisphere acting on the right hemisphere. If you look at McGilchrist, he can refer you to why I would think of it that way. So internal space, which is the left hemisphere mapping the right hemisphere, has to do with these are the closest approximations to the way that I could think about it, because these aren't exactly right. There's no good system for this kind of self-referential long-term, short-term neural network system that's been created at DeepMind for the sake of mapping the self referentially in terms of abstract archetypal memory. But you can see that there's a difference in the way that I've named them. So introvert intuition here is will, whereas here it's vision. So you can enact an internal consistent will to an internal space of vision, which would be different than extrovert intuition, which when it's in terms of consistency is a kind of connection within an exploration space. So an introvert feeling, you'd have value, which is acting as a consistency within imagination space. An introverted sensing, you'd have an archetype, which is acting within an internal memory space, which these serve to map the external. These serve to map the external as well. But these are external functions, whereas these are internal functions. So that's the difference between the way these are set. See what I have here. Yeah, so there's a lot of convolution that I'm associating with the idea of vision, imagination, internal space mapping, and I just think of that as stronger than gradient descent on a narrow, weak AI, but it's still not exactly what's intended, obviously, by this. This is one of the areas that of course needs work, whereas this one is just a promising version of probabilistic and differential programming. Obviously this one also needs a lot of work. I would say that internal consistency is the area that AI has mostly succeeded, and some of these are actually extensions of this kind of functionality. Alright, but let's just move on to the last one, extroverted consistency. So obviously deep belief networks are not actually associated to the connection of beliefs in a system, but there is this kind of meta cost or reward function system, which can have an interval of confidence. So there's upper confidence reinforcement learning algorithms that use a kind of spectral method to define variations. It's kind of a belief system on its decision, but it's always in the sake of an optimization. So that's not, it's still in terms of this will concept instead of the connection concept. So it doesn't have this way of making consistent the exploration space yet. There's nothing in artificial intelligence programming that has that. And then I kind of mentioned here KL divergence, visible and hidden layers, this kind of relationship between RBMs and the unsupervised learning. But most people would know those aren't really good examples either. I would say that one that is kind of a good example is machine learning in general, is this kind of extroverted consistency space mapping. So this is kind of one of the exceptions outside of the internal consistency groupings of our AI programs that are actually pretty effective, which is recognizing and categorizing objects, usually by vision. But this, as soon as it gets into time series data, it becomes more like the symbolic language coding of the archetype logic loop. So the perception knowledge loop is another area that AI has kind of gotten better, and the convolutional neural networks have optimized this very well, which kind of just goes to show why actually these aren't a good example for vision imagination loops. So I would say internal consistency and the perception knowledge side of external consistency are the main areas that artificial intelligence have been acting on. Let's see. Yeah, so there's different kind of systems that I've just kind of listed out here that kind of use to help kind of place something in each of the possible categories. And then I just had some cool ideas, like in the future they'll probably create the theoretical machine learning models that have stochastic overlays, so that you can always be producing, if you think of the left hemisphere, the internal part, as always constantly trying to reduce the external game space and increase the internal game space, and then vice versa for the external game space, then the stochastic overlay on whatever data input you have, whether it's recurrent data from its own output or from some kind of sensory-based information, or whatever exactly the input is, you would have variation, so that it's not going to explicitly focus on the construction of internal game space or external game space, so that it's not the equilibrium between these two selection style strategies are fundamental to enabling the construction of meaning. And it's kind of a deeper theory that I think is why we need the local orchestrated quantum reduction algorithms, because fundamentally each of these is associated with a time orientation. So if you're concerned with intuition, you tend to be concerned with the future time orientation. If you're concerned with sensory perception, you're typically concerned with past time orientation, or present up to present. So it's limited in this kind of SI as past, SE as present, NI as specific future, NE as many possible futures. SE is considered present, but it also is shared sentiment, so it's this kind of shared past. I think it's the only one that has this kind of limitation as it approaches the present moment, that it includes it. But there's no time orientation on thinking or feeling, whether introverted or extroverted, as looped with any of the other functions. So these would go one way and the other way. So the loops would be 6, would be 24 total. All right. Some basic things like 2 Minute Papers is a good YouTube channel for simulation-based AI research. Deep Learning TV is a good YouTube channel as well. I kind of put some big names, just like Demetrius Savas, Tannenbaum, Jeff Hinton, I don't know if I missed any, Andrew, Stephen Wolfram, Elon Musk. Just generally a kind of prediction, I think, on Elon Musk, on his DeepMind and OpenAI being the ones to figure out this area of the internal space, which I think is the area that requires the most work, as this area seems fairly covered. This area seems like it's going to be developed regardless of what happens, and this area seems beyond us at the moment and dependent on this area. So yeah, internal space modeling seems to be the most important. Currently it's just a lot of collection of perceptual based data that just gets used for internal consistency. There isn't a feedback loop between mapping that data to the external space. I think maybe there are some systems where they're connected to a current neural network that enables them to have kind of a say in what their future input is, usually for visual data. But I don't think that they've successfully mapped internal spaces such as to have some kind of sense that you would say of abstract memory or imaginative vision of what kind of goals they would have in that mapped internal space, hypothetically, or what kind of abstract archetypal memories they could form out of their existing memory space. So this is, I think, the biggest problem. The bottom, I just kind of specified that, well, first, our extrovert intuition is the primary cognitive function. From it, you get, if you think of initial evolution and chemotaxis, a species, not a species, but just a singular cellular organism exploring in terms of it develops a valence for a specific chemical. It's the original version of the olfactory system develops a valence so that it becomes will, and from that you develop different kinds. That's essentially the beginning of a sensory system. So you get different kinds of sensory systems. Eventually you develop an eye, actually fairly early on. This lets you develop a valence for light, which then allows you to have this system for archetypal conditions under which you have some kind of gradient field instead of just a valence, which then develops into actually morality after a long time of evolution. Whenever you develop a hormonal system, usually in placental mammals, although I can't say for sure in all planets that you always develop a system of morality with placental mammals, but you do need a complex hormonal system. So the initial connection, exploration, extrovert intuition doesn't seem to have any localization in the brain. It seems to be a general aspect of neuroplasticity, at least my central claim about that. Although because of the quantum reduction algorithm idea and the time orientation being all future, it seems like it is actually that which is not reduced. There's the narrow AI, which can be weak or strong. It basically just means if it's weak, that it's specific to a specific kind of task, kind of like a Turing machine that's non-universal. And strong would be deep, analogically like a Turing machine, because these would be AI systems. And strong would be deep, so it's something like a recurrent neural network or convolutional neural network with a lot of layers that is able to very deeply solve a specific kind of problem, a narrow problem. So like chess would be like AlphaGo, AlphaZero are strong deep systems. Then there's we could say it's slightly general, but it's not generally general. There's general weak systems and general strong systems. So it seems to me that there is a combinatorial sense of intelligence. So the initial version of these single cellular species that have this capacity to explore, so they develop some kind of motor ability. They'll develop this kind of valence based off of certain chemical conditions or chemical gradients, which will determine a specific kind of chemotaxis, so they'll have a receptor, etc. So there's first species that's just any. It loops to any, so it's like ergodic, any to any. And then there's any to ni, and ni to ne, and then ni to ni itself, or any to any itself. Then eventually you develop SE, and you have any to SE, SE to any to any, SE to SE, NE to NI, NI to NE, SE to NI, NI to SE. So it becomes a power of two system where you, with this combinatorial growth, you get what I call super intelligence. So you can have super narrow intelligence, or you can have super general intelligence. And then, of course, to have general intelligence, I assume that you need to have a quantum system. So more than likely, any system that's going to be a super general intelligence is going to be combinatorially quantum. And the quantum, what it really means is you're able to reduce the system into a specific time orientation. So if you have a system that's intuitively focused, it'll be future time oriented. Sensorially focused, it'll be past time oriented. Up to if it's specifically SE over SI, it'll be more presently time oriented. So you've probably heard of Jungian Psychology. If not, it would be helpful to learn about cognitive functions through C.S. Joseph to get a better idea of why I'm using it as an analogy for brain regions and feedback loops that would be associated to different kinds of artificial intelligence programs. So I'll just kind of cover the whole board at once.